Video number 265, finding inverse trig functions or inverse trig values using arcsine and arccosine. Let's take a look. Arcsine is the inverse of sine. So obviously when we use sine, we give sine the angle and then sine gives us the ratio. Well, arcsine, we're going to give the ratio. Arcsine is going to give us the angle that would have been formed. Now, in order for us to use arcsine as a function, so if you want to do y equals arcsine of x, we would need to restrict the domain of sine of x. Why? Because if arcsine is the inverse function of sine, we would need sine to be 1 to 1. So therefore, that's why we have right here. We're only going to use from negative pi over 2 to pi over 2 because during that interval, now this is y equals sine x. This is y equals sine x here. During that interval, we are what? 1 to 1. Then, right, by graphing, instead of negative pi over 2 comma negative 1, I graphed negative 1 comma negative pi over 2. And I got over here. So I just basically did an inverse. This is y equals arcsine. I know it's not the best graph in the world, but nonetheless it gets the job done. Another thing you might want to be aware of are your decimals. You have 1 over 2, then you have root 2 over 2, then you have root 3 over 2. So root 2 over 2, that's that 0.7 number, and then root 3 over 2 will be the 0.8606, okay, or 0.866. Just check your calculator, all right? So that's what you have to remember there. Now, when we do cosine, all right, because eventually we're going to do cosine and arccosine. Here's cosine's graph. So you may want to refer back to some of the cosines and sines to refresh and double check. Notice here, we're only 1 to 1 from what? 0 to pi over 2. Therefore, you can do an inverse function over that interval and call it y equals arccosine. So this is y equals sine x, and then by reversing, instead of graphing 0 comma 1, we're going to graph 1 0. Instead of graphing, what is this one? Pi over 2 comma 0, we'll graph 0 comma pi over 2. And instead of pi comma negative 1, we'll graph negative 1 comma pi. We get this. Now, what ends up happening here is you end up getting just those three if you look at it, but there's going to be the curve here because you have to remember which ones where your 30 degrees, where your 60 degrees are. Now 30 is pi over 6 obviously, and then of course 30 is pi over 30 degrees pi over 6, and then 60 degrees pi over 3. So you just go from there. Now the way I actually remembered this is this. I like to think of arcsine as something very similar to y equals x. Then I like to think of arccosine as being similar to y equals negative x. See that it kind of allows us to work with this a little bit. Of course, this is y equals x, pretty close to y equals x. Of course, you have the curve there because we have it's a sine wave. Now, this is not necessarily y equals negative x. It is kind of like y equals negative x, maybe like plus pi over 2. So you're going to have that pi over 2 there as the y-intercept. So at least it'll give you a little bit of a way to remember that your cosine has the kind of the negative slope, and then, arccosine has a negative slope, and then arcsine has the positive slope. It's very similar to y equals x. This is similar to y equals negative x, I guess, plus pi over 2. Anyhow, you're just going to have to practice in order to get good at it. Here are these 4 that we're going to do in this video. We're going to calculate y equals arcsine of root 2 over 2, and that's this one right here. We are referring to a 45-degree angle. And of course, you can always refer to your little cheap graph we made, and you just try to take a look at wherever root 2 over 2 is, and that will give us a 45-degree reference angle, which is pi over 4. Okay? So knowing your 30, 60, your 45, obviously that's the best way to go here. Let's go to the next one, which is y equals arcsine of 1, and that is right here. Where does sine of pi equal 1? Well, that would be a 90-degree reference angle, so we're going to use pi over 2. Let's just double check and make sure that was true on our graph. Yeah. 1 comma pi over 2. You're all set. And then obviously it's an ordered pair too. I mean, this is an x value and a y value. Alrighty then, next one. I think we're on cosine now. Yeah, we'll do another video for cosine. Whatever, we'll do cosine here. Alright, y equals arccosine negative root 3 over 2. And for that one, we're going to use a 30-degree reference angle. And just have to figure out where you are. Where are you? You're in the second quadrant. Over here, therefore, for cosine, you're going to be above pi over 2. How much further up? Well, you have to figure out 30-degree reference angle, so you're going to use pi over 6's, 5 pi over 6, you're all set. So negative root 3 over 2, comma 5 pi over 6. And I'm glad I didn't do an extra video because this is the last one. Last one is y equals arccosine of negative 3. And think about it. Think about it. Do you see negative 3 on this graph? No. Therefore, arccosine of negative 3 does not exist. So therefore, we would just say it does not exist. So, good times, and we'll see you in the next one.